Okay, in perfect square, we already studied what is perfect square and how to find out a given number is whether the given number is perfect square or not. What are the steps to be followed? Okay, but thing is we need to understand. First, suppose for example, if suppose 16 is there, 16 can be written as 4 into 4. Can you tell 16 is a perfect square? Definitely, because 16 is equal to 4 into 4. Similarly, 144 is there. This is also perfect square because this can be written as perfect. But thing is, when the number is very large, we need to follow some steps. The logic behind finding the perfect square is why we are going to follow the steps. Like first step is prime factor. We are doing prime factorization, isn't it? Prime factorization we are doing. Okay, what is the logic behind all those things? What steps? Number one is we are given number is converted into given number, whatever the given number, we are going to express given number is expressed. Okay, given number is first step. What we are doing is very simple. First step, given number is expressed as product of prime factors. Okay, second steps, we are going to group the factors in a pair. Third step, if suppose if no factor left, already stored these things in previous classes, no factor is left, then the given number is perfect square. Okay, my question is why these steps to follow to find out the given number is whether perfect square or not? Why? What is the reason? What is the logic behind this? We have to understand. Why we are going to express the product of prime factors. Next we are going to group the factors in a pair, and if no factor is left, the given number is perfect square. If some factors is left, the given number is not perfect square. Then we are going to take one factor in a one take one factor, take a factor from a group and multiply to get number whose square is given number, whose square is given number. Why? These are the steps given number. Why we are going to follow these steps? Very simple. For that I will tell you. See, in order to understand, let's suppose, for example, let y be the perfect square. Maybe a number is a perfect square. Assume, okay, perfect square. Definitely, y can be expressed as some x square. Definitely. First, assume that case 1, okay. X is not a prime number. Assume that X is not a prime number. In this case, what happens? See, definitely y is equal to can be written as x into x. Can you understand what I'm telling? Okay. Why I will tell why these steps to be followed to find out the given number is perfect square or not. I am telling these things. Okay, very simple. See here, when x is not prime, of course, when x is prime, I will tell these things. Same rules comes here. Assume that, but x is not prime. X is not prime. Any number which is not prime can be expressed as product of unique prime factors. This is very interesting characters of a numbers. Product of unique prime factors. See, unique prime factors, any number which is not prime. Try to understand. Any number which is not prime can be expressed as product of unique prime factors. For example, you can take any number. Suppose 4 is there. 4 can be expressed as 2 into 2. Take any number other than prime. 81. We can express as 3 into 3 into 3 like that. 3 into 3. 9 into 3, 27. 27 into 3, 81. Like that, assume that this can be expressed as some prime factors like a into b. Here given is perfect square. Y is the perfect square. Definitely x is same number. This can be expressed as a into b only. See here, these are the prime factors. Where a and b are the prime factors. Now, when x is expressed as a, see, same, what happens? Whatever the x has prime factors, then here equal number of prime factors comes here. Therefore we can make the prime factors in a pair. We can group it like this. When it is possible in only when y is equal to, can be expressed like this, y is equal to x into x. Then only it is possible to make like this group. This property we here using here, grouping the factors in a pair. If no factor is left, then given number is perfect square. Can you understand what I am telling? Again, in order to find x, means you have to find out the number whose square is y. What we can make? You can take a common from this pair and again b common from this. What we get is nothing but the x only. In order to get these things, you have to take one factor from each pair and we are going to get again x here. This is the logic behind the steps to be followed in a vectors. Suppose case number 2, what happens? Case number 2, case 2, for example case 2, x is a prime number. What happens? Sorry, I will tell clearly. I will start here. Okay, suppose case 2, x is not a prime number. X is a prime number. For example, x is a prime number. What happens in this case? Suppose 4 is there. 4 can be expressed 2 into 2. 9 is there. 3 into 3. Y is equal to x into x. What happens? You can get directly the factors here. 2 factors. You take one factor directly. In case x is a prime, means x is itself gives the answer. Because there is no further x is itself gives the answer. Okay, to take suppose for example as I told you, 4 is equal to 2 into 2. Directly you are expressing, you are making it a factors in a, we make a only single pair. You have to take one factor common, that is 2, to get, can say directly this, the given number is perfect square. Given number is perfect square. One thing I want to tell you here, very simple thing. What is that? You know, you verify all the prime factors. The prime factors, prime numbers I can say, prime numbers are not the perfect square. Prime numbers are not the perfect squares. Very interesting thing. You can take any prime numbers. Is it a perfect square? No. You take any number. You can take LE1. No, it is not a perfect square. You take 13. Is it perfect square? No. You can take 17. Is it perfect square? No. Small numbers 2 not is a perfect square. 3 is not a perfect square. 7 is not a perfect square. 5 is not a perfect square. The prime numbers are not perfect square. And one more thing is, any number other than prime numbers can be expressed as a product of unique prime factors. Unique prime factors means unique prime factors. This is very interesting. Okay, you take any number other than prime. For example, other than prime numbers. Okay, for example, you can take 18. This can be expressed as 9 into 2. This can be expressed 3 into 3 into 2. This uniqueness, this factors 3 into 3 into 2 will never come to the any other number. This is I am telling unique prime factors like this. Okay, first you have to, now so far what I told is simply what is the perfect square, perfect square always. But why we are going to follow the steps like this? What is the logic behind? Simply remembering these steps without knowing why we are following these steps and all those things. It's not interesting and it's not good also. Just understand why the steps are need to be followed like this. What is the logic behind these things? Then you can go. Okay, these are the things.